Hello everyone. Today I'm gonna give you a talk about decentralized autonomous organizations and especially AI agents and how they are redefining DAO governance. This is a more advanced talk, so I won't be explaining everything, but I hope you all can follow along. On the agenda for today, what is a DAO? How does DAO governance work? Then problems with DAO governance, then AI agents using RAG, and then we end with quantitative reasoning and if we have created a better world through our new decision support system. First, for those of you that don't know what decentralized autonomous organizations are, first, they're very deep in the blockchain ecosystem. So on the top layer, you're looking at blockchains such as Ethereum and Solana, and they serve as a foundational layer for the infrastructure. And then on these blockchains, you have protocols like Uniswap, Aave, and MakerDAO. They represent the application layer on our infrastructure, the blockchains. And they provide autonomous financial services to a degree. For example, Uniswap has, Uniswap does the swapping of tokens. Aave enables you to lend tokens, and MakerDAO creates stable coins for you that you can use in these decentralized applications. And these protocols operate independently on the blockchain, and they can run forever, basically. That's the promise of dApps and smart contracts. You deploy it once, and you don't need to change the service. But we have an option on how to change these services on-chain. Even though they're immutable, we can use DAO governance or decentralized governance to change the inner workings of the protocols. For example, we can fine-tune parameters, we can fine-tune the fees, we can fine-tune risk parameters, and that's what we have DAO governance for. Examples of DAOs, as I just mentioned, are Sky, formerly known as MakerDAO, for creating stablecoins, Uniswap, which is now at Uni, and, for example, NounsDAO, which is a collective of NFT holders. Now to how does DAO governance work in theory. This is split in two parts, with the theory and with the reality. In theory, we have all the great things that we were promised over the last years, and in reality, you have my insights as the Chief Technology Officer of the leading, DAO delegate on how it actually works. So, in theory, token holders, for example, Aave holders, so you have the Aave protocol, which has the Aave token. Then you have the Uniswap protocol, which has the Uni token, and the Sky protocol, which has the Maker token or the Sky token. And they build the foundation of the governance layer. So in a sense, you own the token, and then you can participate in DAO governance with the token. Mostly it's token-weighted governance, so as many tokens as you own, the more weight your decision has. And the token holders, they are stakeholders, and therefore they have an interest in the protocol becoming more valuable. So your general drivers, you buy the token, and you make good decisions to make your tokens more worth because you did so many great decisions on the governance. And there are tens of thousands of token holders in each of these protocols. So Uniswap, for example, has 100,000 or even more token holders that all collaboratively decide on what's going to happen next. The token holders, they create proposals to optimize the protocol and therefore increase the KPIs. And they work like a hive mind, in theory. The reality, many of the token holders are small token holders, so most of them have like 10, 20, $50 in tokens, maybe $1,000, but mostly not that much more. And you have a real concentration of power within certain individuals. For example, A16Z Crypto has invested heavily into Uniswap when the protocol was early, and they have delegated the voting power to several, we call them delegates, 2.5 to 5 million Uniswap token at a time, which kind of equals the US dollars behind it. And then you have like Dragonfly Ventures, who delegated a lot of voting power in Arbitrum. And now you have you have a space where you have the delegates, which have millions of dollars in voting power, and then you have retail, which collectively also hold millions of dollars in voting power, but distributed over a lot of people. Major token holders do not vote in general. So A16Z does not vote due to legal reasons or other reasons. Yeah. And then these delegates assume the role of the stakeholder and therefore doing good governance. Yeah, from my research, here's 2 charts of how voting power is distributed among the DAOs. You can see that the number of deciding votes on the right chart you need like 10 people to vote to get your proposal passed. Even though you have like 10,000 votes possible, you just need 10 votes to pass a proposal. And if you look at the cumulative percentage of deciding votes, you can also see it's very unfairly distributed. So bottom line, retail users don't have a lot to say in DAO governance. Then the next problem. Delegates that get the tokens delegated are interested in their own agenda. Most of them double as service providers because delegation itself takes a lot of time. You have to do a lot of due diligence, but it's not really profitable. You can probably get like $5,000 a month per delegate out of the foundations, but you actually double a service provider where you, for example, help with audits, you help with software development, you deploy software, you run marketing campaigns, you run incentive campaigns, or you provide analytics services. And the service providers, they have an interest in increasing the protocol revenue, but it's not their primary objective. The primary objective is to sell their services. So what happens is you have the service providers that should be doing the best governance possible, but in reality they are trying to sell the services the best way possible, and therefore not setting the protocol success at the forefront, but their own success. And their own success is also tied to helping other delegates sell their services, because you need their votes to get your service sold. So you help them get their service sold, and then everyone sells their service to a DAO, and all the service providers are happy, which is not the best for a protocol. This leads to the problems with delegates. Corruption, the only way to make money is to sell services. Collusion, help others and they will help you. And then knowledge, decisions are derived from politics and less from actual knowledge. With the individuals, it's kind of different, but they have some of the same problems. Like most people, like imagine you have like $100 in Uniswap token, and then there comes up a proposal to change the debt ceiling of a certain token. You are probably not an expert on it, and you also don't want to spend the time of reading through all of the documents that would make you an expert. Then the size, most of the token voters have less than 0.0001% of the voting power, which then does not really matter if there's people that have 2.5 or 5% voting power. And lastly, the attention. There's a proposal every week coming up in every DAO that you participate. You just don't have the time to read up on every proposal, and there's little financial gain for you to do so. Your time is better spent elsewhere. Possible solutions. In my opinion, delegates are not a solvable issue because you might temporarily prevent corruption, collusion and will even have all the delegates at a state where they know enough to make a good decision, but that's only temporary. Long term, you don't have a chance, and DAOs hate to compensate delegates, so all the work you do is you don't really get rewarded, you just try to sell your service. And so we end up solving the underlying problems with the individuals, which are, in my opinion, a solvable problem using AI agents. For example, the knowledge. The AI knows everything. If you build it good enough, thanks to retrieval augmented generation, and you select the correct data, but more to that later. The size, if everyone votes, then every vote matters. Then as a collective, you can make a difference if you have 100,000 people actually voting through these tools and not just a fraction of them. And attention, AI is always up, except if you misconfigure DynamoDB DNS, which sometimes happens. To the agents with RAG. This is a quick rundown of how you could design such a decision support system. It's not a full rundown, but it touches on the most important parts of it. So, as a starter, you collect as much good and structured data as humanly possible. For our use case in particular, you need on-chain data such as transactions, events, token ownerships, and you can do that with your own RPC, which is a node in the blockchain network. You can use the Alchemy API, you can use Infura. You have to get then the prices, for example, for Bitcoin, Ethereum, all the tokens of governance that you need and want. You can get those from CoinGecko or CoinMarketCap. After you have collected relatively unstructured data, you store them properly in a relational database, preferably. You can also use not only SQL databases, but they are harder to use, in my opinion, and worse for this use case. For these, you create embeddings using vector extension Postgres, which is awesome to use. Like, you just install it, then it works. And then you can use OpenAI embeddings, for example. Important here is that if you have too much content, let's say your proposal has like over 4,000 characters, you do need to compress it first, because embeddings get exponentially worse the more characters you put into them. So keep it below 4,000 characters if possible. Then summarize the context with a Flash model. For example, Gemini 2.5 Flash works pretty well, but you could also use any nano model from from Anthropic or OpenAI. So it doesn't really matter as long as you summarize your context first, then you use an embedding model, and then you store these embeddings in your relational database, and then you create a link between your embeddings and the actual documents for the retrieval later on. After that, you can create your agent, which is not really an agent here, but it's a large language model calling tools. So first, you create a tool that retrieves documents from the database, your SQL tool. LangChain also has built-in options to just retrieve documents by passing a vector, so they have a pre-built tool for this, but you can build one of your own. Then you can create additional tools as needed by your use case. For example, I need up-to-date blockchain data that is maybe not always embedded in your database. I need the prices of right now, things like that. And then you connect a state-of-the-art model like a Sonnet 4.5, a GPT-5 High, something kind of expensive. So you're not looking for Flash models here, you're looking for an actual reasoning model. And then you can connect it to a front-end of your choice. The Versal AI SDK is a great choice for starters. It's open source. You go to GitHub, you clone the repository, and then you just connect it over a custom provider, which is fairly easy to do. So you can get up and running in like 4 hours if you really put work into it and if you get help from your coding agents. There's also a hard way. You can use LangGraph, which is a more complex version of LangChain, which allows you to use different agents and agent orchestrators that each use different tools. They can run in parallel. So, for example, you can use a supervisor, some fast model. Like if you have a small model and use that as supervisor, if you have a large model and use that as supervisor, your answers are gonna take like 10 minutes because the supervisor has to look into every artifact that gets out of the smaller agents, and then things get messy. So you create a supervisor, then you create some sub-agents, for example, one to run the document extraction in parallel, just creating the SQL queries, retrieving the documents from the database, and then providing it to the next agent, which summarizes the documents, because we do have still context windows, which are like 1 to 2 million tokens. If you want to use like 10 million tokens, you're going to pay a lot of money for that. It costs like $25 for 10 million tokens if you use state-of-the-art models, which is not so nice. So you summarize them first with a flash model, and then you put them to the reasoning. And then want to decide when you have enough context, which will then periodically check for the large language model outputs, which are like, I don't have enough data yet, I can't answer the questions based on the data, and then you go into a React loop where you're like, okay, the one agent didn't get me the right documents, so I need to fetch more documents, and then until this is satisfied, so you can add ending conditions there. With this approach, you can get a POC in about 4 hours, but getting something to work well will take like 200 hours. The issue is like, you will make very fast first results, but actually having the breadth of depth, having the long tail and being able to answer most of the questions, having real good reasoning and not just it works most of the time, is a pain. I'm very sure that the toolings will get better, but for now it remains a major annoyance. So if you plan on doing that, plan in a lot of time. If you want to put this to production, if you just want an internal prototype for your use case, you can get it real fast. Then we come to quantitative reasoning, which is the hardest part. Just getting documents and getting context is not that hard. It's a lot of data work, but it's within limits, and as an engineer, you most of the time know, like, you get the errors with retrieving the documents, you can about see, did I get the right documents, did I get documents, it's all engineering. But at quantitative reasoning, it's very hard to understand if you actually made progress with your application, because one reason, if you're not a complete expert on the field, the reasoning might be off enough that it's not useful anymore. And for that, we have created a approach with a few steps, which works reasonably well. It's not perfect yet, of course, but works reasonably well. So we have a React loop for the reasoning, like 5 iterations. It's the same as you have in your IDEs, or if you go to ChatGPT, you ask a question, and you see these gray little thinking texts. We have like 5 steps of these to understand the request better, to understand what everything is about right now. And then we have a summarized tool for the proposals to get the context better. We have a lookup for the discussions, which is so there's proposals where people propose something to change the protocol. There's discussions where people discuss something. And here we have a tool to just look up the discussions and search the history, which gives you, we just gather data basically. And then we do something called the multi-delegate perspective. So what we do here is we look at real people and how they have decided over the last 5 years, what they have commented, what their opinions are. And with that, we can get delegates that are heavily driven by personality embedded into a large language model. So we feed all the documents, all the past reasoning of real persons or clusters of real people. So people with about the same opinion, we cluster them. And then we create profiles. For example, the conservative, which does risk assessment focused, progressive, balanced, governance focused, synthesis focused. So we get all these different perspectives. And using that approach and the different perspectives, we can now create a base reasoning artifact. So we get a new proposal, and then we run this base reasoning, and then we get these parameters. We have a proposal summary, we have key arguments, we have voting options, similar proposals, reasoning trace, and preliminary insights. These we then mix with user profiles, because if you want an individual to have their voice heard instead of just following the mass, you need their specific profile, like what do they want to achieve with their governance. And we then ask for these 4 parameters: risk tolerance, governance priority, financial priority, and others, and a free field text of where you describe what do you want, like what do you want to achieve. And then we mix this with a fast model to generate the final output and then cast a vote on the proposals on-chain or off-chain, wherever the proposal lives. And we have built this. It's not released to production yet, but we have a prototype ready. Here you can see your delegate on the side. You can see the parameters that you have configured it to, etc. And here's an example reasoning. So on the left side, you can see a proposal. This is just a cutoff because slides are not that big. On the right side, you can see the AI analyses where you have the justification and the decision. In this case, against, using the profile that I have created, I should be voting against it. This was run in a co-pilot mode where I get to make the final decision, but you can also run it in autonomous mode where it will cast the decisions themselves. Okay. Did we create a better world with this decision support system? Well, unlikely. We created a POC for a mini part of the world, like DAO governance is not mainstream. Normal governance the government is mainstream. We could, in theory, transfer it to the real world, but you run into the same problems. Even if you clean your data fully, you still run into the same problems, unfortunately. And people in power don't want it, or they block it directly. Like, imagine the delegates, there are like 20 of them. Like, they want to decide what passes and what not. And they don't want retail to decide, because in the end, then all their service provider proposals are gonna get rejected because they're maybe not that useful for the protocol. And in the end, it's a technology. Technology is never the solution. It just helps you to solve a problem in society. And our problem here is corruption and normal human thinking, where you yourself want to make profit and you don't think as well for the greater good. And we create decision support system which help them do better decisions, but we don't create decision replacement systems which don't exist. Yeah, that's it. We have 3 more minutes for questions if you want to know anything.